Hi everyone, this is a basic geometric proof of how Pythagoras works for right-angled triangles. The theorem of Pythagoras is stated as follows. The square of the hypotenuse is equal to the sum of the squares of the other two sides. This can be stated mathematically as a squared plus b squared is equal to c squared. Here's a right triangle, or a right-angled triangle. We've labeled it with sides A, B, and C, where C is the longest side, or the hypotenuse. A squared is the square which has sides of length A, that red square. B squared is the square which has sides of length B, that green square. A squared plus B squared is the red region plus the green region, which is equal to the square that has sides of length C, C squared. That's what Pythagoras is telling us. The area of the red square plus the area of the green square is equal to the area of the blue square. We will show why this is the case. Let's start by remembering our formula. A squared plus b squared is equal to c squared, where c is the longest side, or the hypotenuse, of our right triangle. Now let's construct a large square. Inside this square, let's construct another square slightly smaller so that it will fit inside the large square and rotated such that the vertices of the smaller square lie on the perimeter of the larger square as such. Now, because we have two squares here, we have symmetries in our partitions. So these four shorter areas on the perimeter of the large square will be the same. A. And these four longer areas on the perimeter of the larger square will be the same as well. B, 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 and B. Notice that we have four identical right triangles, shaded here in red. What we want to show is that for the right triangle, a squared plus b squared is equal to c squared. What's the formula for area of a square? Side times side. So for that large square, the side length is a plus b. A plus b squared gives us a squared plus 2ab plus b squared. That's everything inside the large square. Notice that that smaller rotated square has sides of length c. How to capture the area of that? The area of that smaller square is side times side, which is c times c, or c squared. But also, the area of that smaller square is equal to the area of the larger square less the area of the four right triangles. What's the formula for area of a triangle? It's half base times height. So for any one of those four right-angled triangles, that would be half a times b. 4 times half ab is equal to 2ab. So, if we subtract the area of those four triangles, which is 2ab, from the area of the larger square, which is a squared plus 2ab plus b squared, we end up with a squared plus b squared. And that is equal to the area of the rotated square inside the larger square. And we also know that that is equal to c squared. Hence, we get a squared plus b squared is equal to c squared. Examples. Consider the simple figure here, which is a square, the unit square, with side lengths of 1. What is the length of the diagonal? Pythagoras tells us the square of the hypotenuse is equal to the sum of the squares of the other two sides. That means the square of the diagonal is equal to 1 squared plus 1 squared, or 2. Therefore, the diagonal is equal to root 2, or approximately 1.414. To finish, here's a brief list of some Pythagorean triples. What is a Pythagorean triple? It's a set of three integer values, that is, numbers without decimals or fractions, three whole numbers, which fit the equation a squared plus b squared is equal to c squared. The lowest set of values we know is 3, 4, 5. 5, 12, 13 is another, 7, 24, 25 is another, 9, 40, 41, and 20, 99, 101. But there are multitudes more of them. This is just some of them. I hope that was helpful. In the meantime, look out for more videos here. Thanks very much.